Hello, this is Ms. Moore, and today during chemistry I'd like to discuss the relationships between pH and POH and hydronium and hydroxide, and how those relationships can help us determine whether a substance is acidic or basic. All right, let's start with pH. As you know, hopefully, a pH of an acid is going to be less than 7. pH of a base is going to be greater than 7, and pH of something neutral is going to equal 7. All right, next let's talk about POH. But before we do that, I would like to show you the relationship between pH and POH. So, pH plus POH is going to equal 14, which means as pH goes up, POH must go down. And as it turns out, the relationship, or POH, is when pH is less than 7, when it's acidic, POH is going to be greater than 7. When a substance is basic, when pH is greater than 7, POH is going to be less than 7. And if something's neutral, pH equals 7 and POH equals 7. Also remember that as the pH or the POH gets farther away from 7 or neutral, the substance is becoming more and more acidic or more and more basic. Okay, let's now talk about the relationship between H3O and OH, or hydronium and hydroxide, for acid, base, and neutral. Hopefully you remember that there is a relationship between H3O and OH. We have this formula that the concentration of H3O times the concentration of OH equals 1 times 10 to the negative 14th. So again, as you increase the concentration of H3O, the concentration of OH necessarily needs to decrease. So let's talk for a minute about where do these H3Os and OHs come from. Okay, well, an acidic solution, whether we're talking about Bronsted-Lowry definition or Arrhenius definition, acids release H's. So let's do a quick Bronsted-Lowry reaction with an acid. So we'll use HCl as an example, and we'll react it with water. And the definition of a Bronsted-Lowry acid is that it will release an H in solution. So the H, so when you get to the product side, we'll end up with Cl, 1 minus, and Cl becomes the conjugate base, just for review. Where did that H go? Well, it went to the base. The base on the product side becomes H3O. So what you will note is that in water, an acid produces H3Os, which means in an acidic solution, the concentration of H3O will be greater than the concentration of OH. And the more acidic, the greater the amount of H3O. And what about the OHs? Well, if we were to talk about the Arrhenius definition of a base, a base for Arrhenius would be something like NaOH. And when NaOH is dissolved in water, not reacted with water, you end up with Na1 plus OH 1 minus, producing OHs. If we were to talk about the Bronsted-Lowry definition, let's take another base. Let's take ammonia. If we have NH3, and this time react it with water. This is a base, NH3, ammonia. Bases gain hydrogens. So on the product side, NH3 is going to turn into NH4. And where did that extra hydrogen come from? Well, it came from the acid. And in this case, water is going to be the acid. The water donated an H to ammonia, leaving OH1 minus. Again, OH. So, either way, Arrhenius or Bronsted-Lowry, bases produce OHs, and the more OHs, the more basic the solution. So for a base, the concentration of H3O is going to be less than the concentration of OH, and for neutral, they should be equal. Okay? So to identify whether something's acidic, basic, or neutral, just looking at the H3Os, you know that an acid's going to have a greater amount of H3Os than OH. A base is going to have a lesser amount. You could also think about the greater or increasing H3O is going to make something more acidic. Decreasing H3O is going to make something less acidic or more basic. Okay, that's it for the relationships. Have a good one.